to do a quick introductory video to magnetism and electromagnetism, which is from Unit 6 in GCSE. So my students have just started it. You can see this is a very old PowerPoint produced by the company called BoardWorks, which I think still exists. This is from 2001, but the course hasn't changed much since then. So this will help you if you just started the topic, you want to do some pre-learning, or you want to do some revision on this topic before you prepare for your mocks. Okay, so first thing they wanted you to know is about the shape of magnetic fields around a bar magnet. Okay, so you need to know the shape and the direction of the field lines. So if you had iron filings, you could sprinkle iron filings on a piece of paper over the magnet, and it will show you the field lines, how they go from north to south here. Okay, so the direction will always be north to south. The problem with using iron filings, although you see the shape of the field, you don't see the direction of the field lines, and the direction would be that which the compass would point in. So kind of a north-seeking compass geographically, if you placed it, for example, here, would actually point to the magnetic south pole. Okay, so geographic north is the same as a magnetic south when you're talking about a compass. So I get my students to learn this method of how you can show the shape and the direction of a magnetic field around a bar magnet or around any magnet compositions using compasses, and place them at different positions around the north and south pole, and then trace which way the arrow is pointing. And if you do it multiple times, you will get this shape field, and you'll be able to show the direction as well. Okay, so direction, if you placed a compass in all those positions where the arrows are pointing, that's the direction a compass would point in. So the north-seeking pole, geographically, is actually pointing to a magnetic south pole. And that's an important clarification to make for your GCSE exam. Okay, so if you get a question like this in the exam, which is quite common in the IGCSE Edexcel, you do need to make sure you know this method, okay? And you have to be able to describe the method. That's a required practical experiment that could easily be talked about in the exam in terms of, do you understand the method and what equipment you would use? Okay, so the strongest position, the field is strongest at the poles, and then weakest as you go further away from the poles, okay? And that's why the iron filings have gathered around the poles. You also need to know that not all materials are magnetic, even if they're metals. So you got to know, for example, there are only 3 elements on the periodic table which are magnetic. Okay, and they are iron, cobalt, and nickel, and they're right next to each other in the periodic table in positions 26, 27, and 28. So atomic number 26, atomic number 27, atomic number 28 are magnetic materials, and that's a good theory, really, of why are those the only 3 magnetic materials. So iron, cobalt, and nickel. But magnets are often made out of steel, yeah, and steel is magnetic because it contains iron. Okay, so magnets and materials, if it's iron or steel, which one would you use? What materials will stick to the magnet? Okay, so this is iron, steel, or nickel. Well, cobalt as well. Okay, so they're just repeating what I just told you. Okay. And then you need to know about repulsion and attraction, and this is known to most primary students, but they could ask you a very simple explanation. So the red and the red would repel. The reds represent either North Pole or South Pole. I can't remember. Let's look in the diagram before. So north is red, and in their color coding, and blue is south. Okay, so red and red, yeah, is that south and south, would repel. Blue and blue also would repel because they're like poles repel, and unlike poles or opposite poles attract. Okay, unlike poles attract, like poles repel. So very, very basic understanding So it's good to do your pre-learning before you go into class. It's always what I recommend. So if you've got some coins and you want to see which ones are magnetics, for example, they've given two examples of steel and gold. Well, steel is magnetic because it contains iron, and gold is not magnetic. So that's an application or a use of magnetism to separate, for example, aluminium cans from steel cans for recycling. That would be a good application, and you could get a question like that in the exam. Okay, so unlikely to do it with steel and gold, but it would be a good way if you got a lump of gold and you want to remove all the non-gold from it. The gold would stay behind, and you could take away all the trashy metal or cheaper metals. Okay, what does the magnetic field for a bar magnet look like? Well, we've already done that. So in which direction do you have to draw the fields? North to south. Okay, we covered that in the first slide. Okay, so magnets are made from which materials? Iron or steel usually. Permanent magnets are better made from steel. Iron is what's called a soft magnetic material, whereas steel is called a hard magnetic material. And you need to know that as well. I'm not sure if these slides cover it. We'll see. So, for example, iron makes a good electromagnet because it's easy to magnetize, but it's also easy to demagnetize. So if you want an electromagnet, use iron. If you want a permanent magnet, which is more difficult to magnetize, but once you've magnetized it, it keeps its magnetism for longer. So that's a hard magnetic material. And what are the ends of magnets called? They're called the poles. What do we call the area around a magnet where the magnetic force exists? Field lines, or the magnetic field. And those field lines are the direction a compass would point if placed on those positions, at those positions. What does the word attract mean? Pull together. What does the word repel mean? Push apart. So this is useful if you're learning for the edXL, IGCSE, and English is not your first language. Okay. Revising magnetism 2, here's some questions. What will the two north poles do if brought together? You have to use the word repel. And what will they do if two south poles are brought together? They also repel. And north and south pole will attract. What materials are attracted by magnets? Iron, steel, plus cobalt, plus nickel, and anything made of them. So you could have alloys like steel made of cobalt, nickel, etc., and they will be magnetic. Is magnetism a contact or a non-contact force? You should say non-contact because you can actually feel the force without touching the magnet. For example, if you bring another magnet close to it, the North Pole will repel each other, and they're not actually touching each other. Okay. Electromagnets, on the other hand, use DC currents usually to create a temporary magnet. So when you switch the current on over here, what will happen is the current's going around insulated wire. So many turns of insulated wire wrapped around a piece of iron. This is an iron nail or a steel nail. And if you use iron, it increases the strength of the magnetic field that the coil is producing, or the current in the coil is producing, by up to 50,000 times. So that's important knowledge. Okay, so one of the sides of the coil will become the North Pole, one of the sides of the coil will become the South Pole. There is a way of remembering it, yeah, and when you come to revise for your exam, any of those revision books like the CGP, which are the ones most students use when they're revising, will tell you how to remember it if you need to for your exam board. Okay, so an electromagnet is a temporary magnet, which is a magnet made out of electricity. Okay, so if you actually put the magnet on here, I think the animation doesn't work. As soon as the current is switched on, these paper clips will be attracted to the magnetic field and they will be able to be lifted. Okay. So to make an electromagnet, what do you need? You need batteries, insulated wire, and an iron nail or something. That's as simple as you would do perhaps with primary school students. And I'm sure everyone has at some stage in their education made electromagnets. Okay. So if you want, they could give you an experiment. They could say a student did this experiment and they give you some data, you've got to be able to interpret the data that they give you. In this case, they're saying if you have more batteries, you'll become a stronger electromagnet because more current is flowing, and as you increase the number of batteries. So this is kind of very, very basic independent variable, which would change the voltage, which would then change the current because the coil hasn't changed, and it would pick up more paper clips. So this is a very simple experiment, and they do ask you about scientific investigations in any topic. And then you could also make the magnet stronger by having more turns of wire on the coil. So you wrap double the number of turns, it should be twice as strong, and therefore pick up more paper clips. And that's a very common practical used with younger students especially, but they could ask you about this in GCSE as well. Okay, ways to make an electric magnet stronger then is more turns on the coil, more current going through it, so increase the batteries, and use an iron core, which is often forgotten that without the iron core it would be a very weak electromagnet. Okay, and if you turn it says what happens if you turn the battery round and the electromagnet? Well, the poles will reverse, and the poles of the coil reverse because north and south. North will become south and south becomes north, because the direction of the current through the coil determines which side becomes north and which side becomes south. Okay, and here's some questions for you to check. What do like poles do? Yeah, well, like poles will repel each other. Next question, which material below will not stick to a magnet? Okay, and that's an aluminium can. That will not stick to a magnet because all the rest are steel or iron. Which below will not, of the answers they should say, will not increase the strength of an electromagnet. So it looks like some typos in this question. Which will not increase the strength of an electromagnet? Well, less current will be the opposite. It will make it weaker. Okay, you want more current. And then in which direction do magnetic field lines always point? You should know that from the earlier slides, and that's north to south. Okay, so that's the end of a quick revision of what you should know before you go into GCSE on the topic of electromagnets. I thought it would be useful, as my students have just started it, and I'd like them to check what knowledge they already have from younger years before they start doing GCSE level questions. If you found that useful, please show your support by liking the video, sharing it with any friends you have. This will be useful for anyone doing either lower school science or doing preparation for GCSEs. Okay, and subscribe if you want to know when I do some future videos. I'm starting to make smaller videos of any PowerPoints that I've got on file, which will help you just tap into a variety of topics before your mock exams. Okay, thanks for watching, and hopefully see you in the next video. Bye for now.